This is an assignment related to alcohols and halogen alkane. First 18 questions I have already solved. So question 19, halogen alkanes are the important intermediate organic in organic chemistry. The scheme below summarize some important reactions are there, A, B, C, and D. Identify a reagent and any specific conditions which are required in each diagram. You may assume that suitable temperature is maintained in each reaction. If you want to convert halogen alkane into alkene, like what basically we want to do, we want to produce an alkene from the halogen alkane, or we want to remove the Br, one of the Br and another one is H. So what we can use, if you want to convert halogen alkane into alkene, so we should use alcoholic potassium hydroxide or sodium hydroxide. If you want, the B means we want to convert halogen alkane into alcohol. So if you want to convert halogen alkane into alcohol, the reaction condition is we'll use sodium hydroxide or potassium hydroxide, but aqueous. Like converting halogen alkane to alcohol, it should be aqueous. If you want alkene, then elimination reaction, it should be alcoholic. For C, if you want to convert alcohol back to halogen alkane, so we can use here bromine, so we can use PBr3. Then in part D, like how halogen alkane convert into amine, so we can react with ammonia, so it will turn into amine. So mention, you have to memorize the reaction conditions for this, but reagents you have to mention mainly. Classify this type, classify the type of reaction in each A and D. A is what? Elimination, and D is what? Substitution, nucleophilic substitution reaction. Nucleophilic is actually because it's a type of reaction to substitution. What kind of mechanism is nucleophilic and type is substitution. So if you just write substitution, that's fine for D. The next one, reaction B can produce where two possible mechanisms depending on, for each of the two isomers C4H9Br shown below, draw the structure of intermediate. So this one is what? This one is a primary. So when we have a primary halogen alkane, means the bond breaking and bond forming will take place at the same time. So this carbon which is having a Br, partial positive, partial negative is there, having H, this H, like two H are there, and then carbon chain 1, 2, 3. So C3 and H7. And then this will be the intermediate, like it will form bond breaking and bond forming will take place at the same time. And on the intermediate, there will be a partial, there will be a negative charge. So explanation, like a tertiary carbon cation, which are more stable. And because it's a primary halogen alkane, that's why the transition is this one. But the second one, it's a tertiary halogen alkane. So first the bond will break, then the bond will form. So when the bond will break, so this will be the carbon cation. And here, tertiary carbon cation is more stable than secondary or primary. That will be the reason. And the first one, halogen like the bond breaking, bond forming will take place at the same time as the molecule is small or there's a space available. Here you can mention due to steric hindrance or more repulsion from the molecule. Then if C4H9I is used instead of C4H9Br in reaction D, The rate of formation of why? Because Ci bond is weaker, like carbon iodine bond is much weaker than carbon bromine bond. That's why this reaction occur at a faster rate. Halogen alkanes are widely used as a refrigerant, such as how halogen alkane cool by changing the state. So mainly what they do, they absorb like greater amount of energy before being vaporized. Two characteristic or properties that desirable in refrigerant. If you want to use as a refrigerant, first thing, it should not be flammable. Second thing, it should have a greater tendency to absorb heat energy before it convert the state or changes the state.